In this question, we're given the polynomial 6x cubed plus ax squared plus 12x plus b, where a and b are integers. The polynomial has a remainder of 11 when divided by x minus 3, and a remainder of negative 21 when divided by x plus 1. So for part A, we're given that the polynomial equals x minus 2 times qx. We need to find the polynomial qx, which is a quadratic factor with numerical coefficients. So the first thing we need to do is solve for a and b. So the remainder theorem states that if you divide your polynomial by x minus a, the remainder is going to be equal to PA. So in this question, if we divide by x minus 3, the remainder should be equal to P3. And our question tells us that the remainder will be 11, so we write 11 there. So this will form equation 1. And in the same way, when we divide by x plus 1, the remainder is equal to negative 21. So we can say that P negative 1 will be equal to negative 21. This will form equation 2. So for our first equation, we'll have P3 equals 6 times 3 cubed plus a times 3 squared plus 12 times 3 plus b. That will give us 162 plus 9a plus 36 plus b equals 11. And when we simplify that, we'll get 9a plus b equals negative 187. This will be equation 1. And for equation 2, we have p negative 1, and we'll substitute that to the polynomial. We'll get 6 times negative 1 cubed plus a times negative 1 squared plus 12 times negative 1 plus b. And when we simplify, we'll get negative 6 plus a minus 12 plus b equals negative 21. And when you simplify, you'll get a plus b equals negative 3. This will be equation 2. So let's solve these simultaneous equations. We have 9a plus b equals negative 187, equation 1, and a plus b equals negative 3, equation 2. So the simplest way here will be to subtract the equations. So 9a minus a is 8a, b minus b is 0, and negative 187 plus 3 will be negative 184. So in this case, a will be equal to negative 23. So we can substitute that back to equation 2. We have negative 23 plus b equals negative 3. So b would be equal to 20. So we can rewrite our equation as px equals 6x cubed minus 23x squared plus 12x plus 20. So now we can actually do part A. The question states that qx is a quadratic factor. So if this is a quadratic factor, x minus 2 is also a factor. That's a linear factor. So we'll divide x minus 2 into the polynomial we calculated, which is 6x cubed minus 23x squared plus 12x plus 20. So the first term of our quotient will be 6x squared. So 6x squared times x, 6x cubed, 6x squared times negative 2, negative 12x squared. And subtract that, we'll get negative 11x squared. Then drop down to 12x. Our next term will be negative 11x. So negative 11x times x, negative 11x squared. Negative 11x times negative 2 will be 22x. And subtract again. So we'll have 12x minus 22x will give negative 10x. And bring down the 20. So the last term of our quotient will be negative 10. So negative 10 times x, negative 10x. Negative 10 times negative 2 will be 20. And when you subtract, you'll get 0. So our polynomial then can be written as x minus 2, 6x squared minus 11x minus 10. In part B, we want to solve the polynomial px equals 0. We already have two factors. We have x minus 2 and also the quadratic factor, which was x squared minus 11x minus 10 equals 0. So we have the linear factor already, x minus 2, and this quadratic factor can be factorized to be 2x minus 5, 3x plus 2 equals 0. So the roots of our equation will be x equals 2 from this linear factor. This will give us x equals 5 on 2. And this factor will give us negative 2 on 3. So these are the three roots of the polynomial. Thanks for watching.